All right, we're back. We're on page 8 of, I don't know, note 16 of Calc C. We're talking about parametrics, and we've talked all about various derivatives that you can have. We've talked about, I don't know what else, concavity, arc length, things like that. We solved some problems. Now what we want to talk about is vector valued functions, but strictly from like an AP Calculus BC approach. So that's what we're talking about. There's not much, right? So if you have mastered parametrics, you basically have mastered this. There's like one new idea. I don't even know that it's really necessarily new. So vector valued function is just a function that spits out vectors. For our purposes, you don't really need to understand that at this point, but that's what it is. So every point that comes out of a vector valued function, right? So you'll have something that looks like here, for example, position function. R of t. So if I give you a t value, you have to give me an ordered pair, and that ordered pair represents the terminal point of a vector. So they're always in component form. So you might have something, if you have a curve that looks like this, then maybe R of 0 will be like this, R of 1 might be like this, R of 2 might be like this, but all we're really referring to is the terminal points. That's all we really care about. So we really just care about the ordered pairs. You have a velocity vector, so you're going to talk about velocity vectors a lot, and that is strictly just component by component derivatives, right? X prime of t, y prime of t, that's your velocity vector. You have an acceleration vector, which is double primes. You can have, so speed, we know is the magnitude of velocity, right? That's like a Calc AB, Calc 1 topic. Speed is the magnitude of velocity. So the magnitude of a vector, if you recall, I would say this is the only like thing you really need to remember. The magnitude or norm of a vector. So if we have the vector AB, the magnitude of that vector is the square root of a squared plus b squared. And so when we talk about the speed of something moving with a vector valued function, it's going to be the square root of its velocity. Well, it's the magnitude of its velocity vector. Speed is magnitude of velocity vector. So it's the square root of x prime squared plus y prime squared. This, you might recall, looks an awful lot like the thing that's inside arc length for parametric equations. And it is that. It's exactly the same, which is why when we talk about distance traveled, it's just going to be the arc length of the position function, which is the magnitude of the velocity vector integrated. So it's the same as it was in Calc AB, the same as it was in Calc 1, right? Distance traveled is the integral of speed. Speed in 2 dimensions is the absolute value of velocity. Speed, when you're talking about vector valued functions, is going to be the magnitude of the velocity vector. Not a big difference. So these are all things that we know. You're not really going to see this notation on the AP exam or in BC calculus, to be honest. When we get to, so if you're in my class and we're going to move on to what's called Calc D, I guess, which is multivariable and vector calculus, we're going to need to know a whole lot more about this stuff. But as far as BC calculus is concerned, this is it. This is all you need. So let's see if we can do a problem. Find the velocity and acceleration vectors, find the velocity, speed, and acceleration when the particle is at the point 1, 1. All right, so first of all, if you're at the point 1, 1, that's going to correspond to t equals 1, right? Because you set t cubed equal to 1, you get 1. You set t squared equal to 1, you get 1 at negative 1. But you need both of those to be true, so t equals 1. So here we want the velocity vector. So I'm going to write r of t again. You should put an arrow over it to show that it's a vector. And I use chevrons when I handwrite them. You could use brackets. I think that would be fine. So v of t, I think you should write as r prime of t. So there's been a recent emphasis, especially if you're in AP calculus, on connecting velocity to the thing that it's the rate of change of. So like it's probably not good enough anymore to just write v of t. You got to write v of t as r prime of t, and then you go from there. Easy fix, easy to remember, but weird. And then a of t is going to be, I'm going to say v prime. You could say r double prime. It wouldn't, they're obviously those are equivalent. 6t and 2. So now let's do this at the point So V of 1 gives me the ordered pair 3, 2. It's a vector, right, with a terminal point at 3, 2. It doesn't actually really matter. I mean, if you just think of these as parametrics, you're going to be fine. The acceleration at 1, that's a 1, doesn't look like it, is going to be 6, 2. Now, speed is the magnitude of velocity, so the speed is going to be the magnitude of V of 1, which in this case is going to be the square root of 3 squared plus 2 squared, so the square root of 9 plus 4, the square root of 13. That's velocity, speed, and acceleration when the particle is at the point 1, 1. Those are your answers. So, I mean, not really bad, I don't think. I'm going to stop this here because I'm going to end up doing something weird. I mean, I've already recorded a video where I solved all this, but I guess I'm going to do it again. I'm going to do it by hand, regret it, and then you can watch the other video where I do it by calculator. Should I do these on the calculator just to like show you? Sure, I should. Let me switch. So I know I think I say a lot that I'm going to end a video and then I don't. I'm going to define R of t as, so that's control to get brackets. Control and open parentheses are going to give you brackets. Control close parentheses gives you braces, and one is a vector and one is a list. So they're actually like different things. T cubed, t squared. Okay, so I can do R of 1. It gives me the point 1, 1. I can find the derivative. So the inspired does not care as long as your dimensions match up. It'll do this. So I'm going to find the derivative of R of t. This is V of t. So now I define that. So I can find V of 1 and get 3, 2. And then I can find the derivative of that. I'm going to say A of t is the derivative with respect to t of V of t. And I'll find A of 1, and I get 6, 2. If I want to find the magnitude of velocity, what I can do is, so this is all like, remember, I'm assuming that you've gone back to your analysis notes, you've reviewed vectors. Where are those in analysis? I don't really know. They're like notes something. 12, 11, maybe 11, maybe 11. I don't know. You'll find them on the website. I'm assuming you've reviewed that. So there's a lot of stuff in there. So it's menu, option 7 is matrix and vector, and then option 7 is norm. We just want the norm, so press enter of V of 1, and it finds it for you. So it also will do that with functions. So menu 7, 7, enter. If I just do V of t, it does it with t, and it like simplifies it for you. And that's going to be amazing for us because when we want to find distance travel or arc length, we're going to just integrate the norm of the vector, and we're going to let the calculator do the work for us. So I will now go back to the notes and then end this here. And then we will do the next part of this page. So getting there. Don't worry about it. We got this. All right, so here are the answers that I had confirmed on the calculator, and I will be back in the next video to finish this page. So see you there.